in the past, all the code we write are in just one file, right? So sometimes it's really hard to maintain because the files can be the lines of code could be very, very long, right? It's very hard to maintain. So if you are working in a very large project, the common thing to do is separate them into different files, and so that different people can work on them together. There are also one benefit is you can save some time while you are compiling. But for most of you, for now, because your project is so small, the compilation may take seconds, right? But in the future, if you have a large project, compilation may take hours or days. So at that time, whenever you fix one small error, right? Fix one semicolon, it takes 1 hour to compile. Fix one error, take 1 hour to compile. It will take a really, really long time to debugging. So we will learn how to separate them into different files, right? So that you can work in groups. Let's look at one example here, right? This is the product class we defined last time, right? Product class. And we separate them into different files, like product.h is a header file, product.h. And we put them implementations in product.cpp file. This is the source code. So in here, you include this product.h, which is a definition of your class, right? In here, some of the functions you can give implementations, some of them you can ignore the implementations. If you don't provide implementations, just the interface, it's called a declare, right? Declaration. I just declare there exists such a function here, but I didn't give the implementation details. The implementation details I could put in my CPP file, right? My source code. So in this way, I'm separating my header and my source code, right? I put everything in here as a declaring this is my class product. I defined my class product in this way, and everyone who wants to use my product, what they only need is to include my product.h, right? Such as in my main.cpp. If I'm trying to use a product, right? If I'm trying to use a product, like creating a product P1, I have to include this product.h, right? And by looking at this header file, I know how to use this code, right? I know how to use it, such as just print, and I just print it. So this is the way we typically split these files, right? For every class, typically, we create a header file, a CPP file. Header file contains the definition or declaration of your class. And in your CPP file, you have implementations. And in another, for example, main file, you will use this class, right? So you are separating them into 3 files. And if you want to have more, such as, for example, if how about your class, class product need some time, right? For example, when this product will expire or when this one is produced, let's call it produce time, right? You can have a produce time, for instance, and you can have a time class. I didn't implement much here, but I just put a class here, right? You can have this one, or you can have another shop class, right? You can define another shop class. In your shop, you have a list of products, right? You can use your classes in this way. And every class definition, right? You could use another class, right? Vector is a class, right? Product is a class. You could use their classes by including their headers, right? Including vector so that you can use vector, include product so that you can use product. So this is the way we try to separate the different definitions of classes into different files, right? So in the future, your folder should look like the left-hand side, have a lot of header files, a lot of CPP files, right? And let's see. So the headers we typically contains the declarations of the non-member functions. Non-member functions means this function doesn't belong to any class. We could define some classes, right? We can define some of the constants. We could also declare some of the global variables. I will touch upon this one later. And the source file, we typically contains the definitions or the real implementations, right? How these functions are implemented, and also the global variables. As you can see, the global variables, I put a definition here, put a declaration here, right? So it will be. Let me give you an example, right? If you want to define a global variable, let me put it here, produce time. If you want to include a global variable, you could say, let's try one first. Let me define global A here. If we want to use this global variable, right? Similar to definition of the class, everyone want to use it, need to include this product.h file. So assuming here I have a product.h, right? In the main file, how about I see out this global A. This is my main.cpp. How about in product.cpp? Because I include product.h, I could also output this global A, right? And if you want to run it, you will see it has failed. It is failed because you have duplicate symbols. You have duplicate global A. Now I have to introduce a little bit about how the compilation works. All right. So in a compilation, let me comment this out. Yeah, maybe later. So in a compilation, every compilation unit is one CPP file. It's not one header file. It's one CPP file. So if you have this amount of CPP file, it will first compile each individual CPP file. Then they are trying to link them together. They are trying to link them together. So what does include do? Include is copy. If you say, I want to include product.h, what I'm indeed doing is I'm copying everything in here, everything in this file, copy them to here, copy them to here. Now it means I have one global A, I have one global A in my product.cpp file, right? And I also have a global A in main.cpp file. Whenever I'm include, I'm doing a copy, right? I'm copying this line in this CPP file. So in these two CPP file, each one have one individual global A. Each one have one individual global A. When you're trying to link them together, because both of them are in the same namespace, it will be a conflict, right? It's a duplicate symbol. So you cannot do that. The way to do it is you have to make it extern. And you can define it in one of the CPP files. For example, I can define it in here. I could say int global A equals to 10. This part, because I'm declaring, I cannot initialize it. All right, so this is the way we can use global variables. Now it can work. This one, remember, include is copy, right? I will copy this line in here. So it says I have one external integer global A. But when I am executing in here, this global A is known, right? This is my global A. But in my main.cpp, when I'm including this product.h, I am also including this line, right? I will put this line in here saying, okay, there exists a external integer called global A. It's not defined by me, right? It's not defined by me. It's defined by someone else. When you link everything together, you are trying to find out which one is global A. All right, so this is how the compiler works. So in main.cpp, it's not defining a new global A. It just says there exists. It's declaring there exists a global variable, right? Called global A. It's declaring. It's just declaring. It's not defining it. But in your product.cpp, it's real defining it, right? If you define it, it's done. And then when you link these two files together, there will be existing a global A. If you don't link them together, and the main CPP will never know which one is global A, and there will be some errors. No definition of global A. But if you are trying to link them together, they know there exists a global A. So this is what you can do, right? So that introduces some of the confusions for students who like to use global variables. So try to use it this way. If you want your global variable to be accessed by all the files, right, you should do that. All right, so let me comment this out. This is a global variable. Let me repeat. I'm not suggesting you to use global variables, but if you really want to use it, use extern in header file and define it in one of the CPP file, anyone, right? Any one of the CPP file. So that's the way you do it. All right, so another thing we want to mention is you need to include the include guards. So this is the typical way to write include guards. If not define some variable, then and if. All right, so let me do this. So in here, I'm just giving you an example, right? For here, for instance, in my time class, in the time header, I didn't include that part of lines. So how about we make it fail in our product.cpp? In our product.cpp, I'm trying to include this time.h. As you can see, first I include product.h. In my product.h, I have included my time.h, right? Because of I'm using this time class, so I include this time.h. This is in my product.h, right? While I am including my product.h, I said it's a copy, right? Copy everything in your product.h to here. So I am include time.h, the first line, right? Then I'm include time.h again. I'm include time.h twice. What is include time.h? I'm copying everything in here. I'm copying everything in here to my include class, to my include, right? Include time.h. I will replace it with the class definition of time, right? So in the first line, I defined time class. In the second line, I'm also defining time class. So there will be duplicated definition, right? Redefinition of your time class. Can you understand this part? Any questions? Why it's including two definitions of time class? No? All right, so in this part, it's including two parts of class time, right? So while you're trying to compile it, there will be redefinition of time, because this header file is included twice in your product.cpp. We said while the compiler is compiling each CPP file individually, right? While it's compiling product.cpp, there will be some errors. So how can we fix it? We need to add in some of the include guards, such as if not define an A, we can define an A, and at the end of it, we say and if, right? It's like a if statement. If A is not defined, A can be anything, right? A, B, C, D, it's also fine. If A is not defined, now we try to define A. So when the first time you are including the time.h, you will define an A and also defining the class. The second time when you say include time.h, because A is already defined, the first line is a false. It will not execute the following lines. So the class time will only be included once instead of twice. All right, this is the usage of the include guards. But if you are defining arbitrary variable name like A, B, C, D, it's very hard to remember. So people typically typically make this variable the same name as your file, like time h, right? If you are in the time header, time.h file, you make this variable the same as the file name. It indeed can be any variable name, but the thing is you are trying to making sure there will be no confusions about it. So because file names cannot duplicate, so this variable cannot duplicate. So if you do this, and then when you compile, it can succeed, right? Because of the guards, this one is only included once. The class time is only included once. And because these 3 lines are too long, so people think about a new way, right? They invented something called program once. Instead of 3 lines, they just use 1 line. Functionality, they are basically the same, a slightly different, but they are basically the same. The difference is the first if not defined is belongs to the standards. So arbitrary, any C++ compiler will know what this one means. This is a standard. And the programmer once is non-standard, it's not in the standard. So you cannot guarantee every machine supports that. It is so widely used, almost all the computers support that. All right, even though it's not standards, but almost all the computers support that. So you can use that one as an example. You can see my product.h. No, this one, shop.h. Yeah, as you can see in my shop.h, right? Instead of the 3 lines, if not define, and if, I just adding 1 line, programmer once. This one means this guy will be included only once. Even if we include it multiple times, it will be common thing people write, all right? So yeah, for the remaining that are easy in your source code, you include the headers, right? And the source file contains the source file typically do not contain a main function, such as the product.cpp. The product.cpp, you don't include a main function here because you cannot decide how people use your class, right? You cannot put a int main here. If you put an int main here, because you have another int main, right? You have another main function, there will be also duplicate symbols. And your computer doesn't know which one to start, right? Do I start with that main function or this main function? So all your programs should contain only one main file. So typically in your implementations for a class, you do not include your main function in the same file. It should be a different file so that people can use it. So as an example, we have shown that in the class of shop, right? In your shop, you have a list of your products. You could do that. You could have a factor of products, but if you would like to use it, you should include this product.h. But because I don't have the include guards, right? If I don't have the include guards for the product, for instance, if you are trying to include this product.h, then shop.h. If you forget about the include guards for your product.h, it will be a redefinition of your class product. You can try that. And let me talk about one thing that we introduced in the first class, which is makefile, right? People typically write a long makefile so that the whole project can be compiled just typing make. So in the past, we say we can write some code like this, right? And if you have multiple CPP files, you can put them together in just here, right? G++-O shop, which means generate a binary called shop. Then you are combining all these CPP files together. What is this one indeed doing is a compiler is indeed compiling each CPP files individually. It will compile product.cpp first, for example, or it will compile shop.cpp, then it will compile main.cpp. Each compilation will generate some intermediate file called object file, product.o, shop.o, and main.o, right? after you compile each CPP file individually, you can link them together. At the end, it's called a link. Link this O file together, then it will make the final binary called shop. So you can try this one. And the reason we separate these files, we said, is to save some time for compilation, right? For instance, if product.h and product.cpp, you didn't change anything. You didn't change the product. You didn't change the shop. You only change one line in main.cpp. At that time, if you already have the product.o and the shop.o, what you don't want to do is you don't want to recompile everything. You don't want to recompile everything. You only compile the file you modify, right? This is the only command line you need to type in g++-c-o main.cpp. You want to generate a new object code for the code you modified, and then link them together, right? So this is the save some time when the project is large. You don't have to recompile all the CPP files, only the files that you modify. And if everything is in a makefile, if it's in a makefile will try to find out, did you modify the file since the last time you compile? It will have some mechanism on that. So as long as you type make, it will figure out which file is modified, then compile it, compile just that file, then link them together. All right, so that's the benefit of using makefile. Because in our project, we don't ask you to include a makefile. I just introduce it here for your information, and you don't have to understand all of them. If you are interested, try and search online, figure out how everything works. All right. So this is the main benefit. Any questions on it? How every file is compiled? We will touch on this one when we go to the constructors. All right, so let's go to our real content, the constructors. So constructors is indeed a little bit more complex, right? We said the first complex is it seems a function call, but it's indeed not a typical function call, right? It didn't return anything, and there are more weird things happening. I will introduce it later. So here is a very simple default constructor, right? We just initialize the price to be 1 and the score to be 0. And this is a typical way, right? We are trying to use the default constructor to initialize the data to some deterministic values. So instead of making them random, we are trying to make them fixed. So for instance, in the product.h, right? In here, I'm making it a const, right? A fixed number. So let me comment this out. And we said, if we don't write anything about the constructor, the compiler will automatically generate a default one for us. Let's go to our main.cpp to see how it is used. I'm just creating one product P1, right? Using the default constructor. I didn't write anything. Then I ask it to print it. Let me run it. And as you can see, it outputs some weird number, right? Some weird number. It's quite random, but it's not sometimes what we want. And we said, if you don't write any constructor, any default constructor, it is the same as asking the compiler to generate a default one. It's just explicitly saying, I am using the default constructor by the compiler, right? I don't want to write my own version. It is exactly the same as without writing it. They are the same. So you can write it or not write it. It doesn't matter. So, but what people typically expecting is you can give it a deterministic values for your members, right? You can put a 1 and a 0 here, and let me comment this out. You can put a 1 and a 0 here, so that each time you called, these values are deterministic, right? Each time the default construction is called, the values are deterministic, 1 and a 0. So we said this one, right? You can use default, ask the compiler to generate a default one, and it only works. It only works if the classes are built-in types, like integer, float, character, right? They are built-in types, and they have a default constructor, or any class that have default constructor. If your class don't have a default constructor, then see here, right? If we delete everything, it means we are using the default constructor. We are using the default constructor, right? And as you can see, it is using this part. This three parts are built-in types. They have no issues. They have default constructors. But there's another one called time. It's written by you, right? If we go to the time.h, yeah, it has a default constructor, right? It has a default constructor. There will be no issues. How about we don't have it? If we don't include it, compiler will generate a default constructor, right? It also will work. It can also work, but how about we explicitly delete it? This is the line that is saying I'm asking the compiler to delete the default constructor for me. I don't need the default constructor. If you do this, because your time don't have a default constructor, your product cannot use a default constructor. If you run it, it will fail because it don't have a default constructor. The reason is your time don't have a default constructor, right? So here you use equal delete to delete this default constructor. So if you do this, you don't have a default constructor, all right? Your time don't have a default constructor, so everyone using your time object cannot have something we meant here. If all the members a default constructor, the compiler can generate the default constructor. If any of them don't have it, you cannot use a default constructor, right? And then you can check how the built-in types are initialized. We said it's quite random, right? All the data are random. And we said it's a good practice to initialize all members with deterministic values, 0, 1, or some empty things. So for now, we only discussed about the default constructors, right? Next, we want to talk about something another way. Let me delete this part. So in our product, for instance, we only have a get name function, right? We don't have a set name function. How can we set the name of P1, right? You cannot say P1.name equals to some name, right? You cannot do that because it's private. Because this guy name is a private member. We cannot assign it, right? And also, we only allow the user to set price. We don't allow the user to set a name. So how can we set the name, right? Indeed, for this implementation, we have no way to set the name. But what we can do is, how about we create a function that allows the user to set the name at the beginning. Then we can take some parameter n, right? And we assign name to be n. Then this constructor takes one parameter. And how can we use it? For instance, we want to create another product, P2, with a name test. And we can call P2.print, right? If we print it, the P2 have a name test. And as you can see, no one can change my name, right? I don't have a public interface to change my name. So that is a typical way to use a constructor, right? Sometimes the values, you want to initialize it from the beginning, but never want the user to change them. You can create such a constructor for it, right? So for this product, you initialize the name to be test, and no one could change it forever. So this is one usage, right? How about more? How about we want not only adding the test from the beginning, we also adding, for example, set the price and set the score, right? We can do them as well. You can copy this part. You can create this one and, for example, double price and give it a name P. So this one can be P, right? You can create another product, P3, with the name P3, this name P2, with some price 100. And also you can add in more parameters, right? More and more parameters as you like. So these are something that we typically do. Remember how we use vectors, right? Remember how we use vectors. We could call the default constructor, right? This is a default constructor. It's a class. Vector is a class. We didn't provide any parameters. And we can call it with some parameters. The same name. What does this line mean? I'm initializing one vector object with 5 elements, right? What we could do more? What does this mean? The same name. I'm initializing one vector object with 5 zeros, right? So how you use this parameter is it depends on you, right? You can write it in different ways, but what I mean is you can call your constructor in many different ways, right? This is the call your constructor in many different ways. Here is also calling your constructor in many different ways, right? You are trying to implement a different functions, right? So that they can call it in different ways. All right, so here is a typical way we write, right? For example, if it's an employee, it contains, for example, the name and a salary, then we can have 2 constructors. First one is a default one. Second one is accepting some of the parameters. And this one is called overloading. The reason is they are the same name, right? Their function names are exactly the same, called employee. The only difference is their parameters. It's not just for constructors. It can also work for any functions. We have shown that, for instance, in our main function, right? In our main function, we could say f function returning an int, for example, return 1, right? We could also say f function accepting some number and returning 1. So these are called overloading. The same function name, both of them called f. Depends on how the function is called, right? If in main function you say f, then it is calling the first function. If you are saying f of 1, it is calling the second function. All right, so that's the, for example, I can change the implementations to be different. Int sum equals to n plus 1, for example. You can do anything to it, right? It will, so compiler will know which function you are calling by checking the parameters. If you don't have parameters, you call the first one. You have parameters, you call the second one. All right, so that's the functions. And also in here, right, because you have a product depends on the number of arguments. It can know which function you are calling, which constructor you are calling. Let's use this one as an example. If I am in here, right, because I only have 1 argument, if I step into the function, as you can see, it's calling the second constructor, right? The first constructor don't accept anything. The second constructor takes 1. The third construction takes 2 arguments. And you can see this one is copied here, right? So that's the overloading. My main.cpp, right? This is overloading. And another topic we covered is called this, right? Remember that this is, let me use this one as example. If my parameter is also called a name, if my parameter is also called a name, if you want to initialize your member name with the name from your parameters, right? This one can be any name. This one can be name, can be n, can be anything. If you want to do this, it will be some errors. So what you can do is you can make this guy this name. I want to assign the argument, right? The parameters to my members. You can use this way, assigning the name to this name, right? So this is how we do it. And we also have another way, which is more efficient, is doing this name with name. In this way, all right? So let me make it longer. So instead of assigning name to some number, we put it after my column, before my braces. So these few lines will be executed before this loop, this body, this function body. This one will be initialized first before I run this few lines. So if I do this, I have a price of 1 and a score of 0, right? I can do this and I can erase that. This syntax you need to remember. This syntax is a constructor before your braces, before your function body. You initialize all the members. This part can only be used to initialize your members. You cannot do anything else. The only thing you can do is initialize your members. All right. It will be run before the body of your function. How can we know that? Let's see. Let me do this. I will see out in here, then call this production time in here. What is this line? What is this line? So this one is initialize my member name with the name, right? With name. I'm initializing my price with 1. I'm initializing my score with 0, right? I also have a member called product produce time, which is a time object. How can I initialize this object? I'm calling a constructor, right? I'm calling a constructor to initialize this object. I put no parameter here, so it's basically calling the default constructor. So let me check the default constructor for time. The default constructor for time, I can uncomment it. So in default constructor for time, I basically ask it to output time construction is called. And in your product.h, I put it in here. And inside of this body, I said product construction is called. So you can check which one is running first. If this function body is running first, I will execute and this line and output product construction is called first. Then I will call this one, right? The time construction is called. If this one is running before the body of your function, it will call time construction is called first. Then output productions construction is called, right? So let's do that. Let me see. Let me just keep 1. I don't need all the others. I don't need all the others. Right, so let's run it. All right, it says time construction is called first. You're executing this, right? Time construction is called first, then product construction is called. So this is the order. You will execute this part, initialize all your member first. Then you are trying to output this one, right? You will try to execute the remaining lines in your body. So what if I remove it, right? if I remove it, it seems like it's not executing. But if you run it, it still says time construction is called. Here, this object is indeed initialized first, the body of your function, right? So even if you don't say name assigned to name will be initialized first, all right? So let me give you an example, is using this. If I put this line here, right? For this constructor, it seems like you are initializing your produce time in the loop body or in the function body, right? It seems like you are doing it, but indeed it's not. Indeed, what you are doing is you will create your time object first, then executing this line, which is calling a time construction the second time, then call this line, right? If you put it after this line, you will see the time construction is called first, then executing this line. Product construction is called, then call this line. Time construction is called, right? So you are not creating one object, you are indeed creating two objects. First object is created in here before this function body. You will create a time object, put it into your produce time. Then inside your function body, when you run it in here, you are indeed creating a new temporary time object, then using this object to override whatever you have done, right? Whatever you have initialized in here. So that's the basic way. So whether you write it, let me go back. Whether you write it here or not, it will be executed and call the default constructor. All right. So any questions? So let me make this problem a little bit complex. So because in your product class, you have an object called time, right? You have object called time. And in your time class, let me make this one a little more complex. Assuming in your product class, you have a class called shop. And in your shop class, you have a product P. What will happen? What will happen? We said in your product constructor, it will try to create one object called a shop, right? It will try to allocate some space so that, and then you can initialize your S. So it will call shops constructor, default constructor. But in shops default constructor, we said it will try to first create a product and call the constructor for P. So it will call the constructor for P. Remember, in P's constructor, it will call S constructor first. S constructor will call P's constructor first. It will be infinite loop, right? It will never stop. So you cannot do something like this. So in the future, we will learn how can we bypass that. Is, for instance, you can make one of them a pointer. In the future, you will learn. If it's a pointer, they don't need to initialize this one. This one can be initialized to be a noun and a noun pointer. And also your compiler will know what is the space for this guy. The space is 8 bytes, right? If it's a pointer, it's an address. Address is just 8 bytes. It can allocate this part of space for you. And it don't need to call the shops constructor. But in shops constructor, it also knows the size of P, right? It only contains a pointer, for example. So using this way, you can try to destroy this dependency. So this is called circular dependency in classes. So you can try that. So in our product class, assuming you have a shop, right? And also in your shop, yeah, assuming you have a bunch of product. Let's make this one simple. Let's just say I have one product. And here, if you are trying to create a shop, wait a minute, I don't need to include this one. You will see it will fail. The reason it fails is because of the compilation is failed. So what does it mean? As you can see in my, for instance, let me use the, assuming now I am compiling this product.cpp. Assuming I am compiling this one, I need to include the product.h. Let me fix it. This one have a product, no problem. And in product, because I have a shop, it says unknown. Let me include this shop. Because both shop and the product contains this include guards, it will include only one copy, right? It doesn't have the circular include problem because it's already fixed. So what's the problem when we are including this product.h? In product.h, we will include shop.h first, right? So we will copy everything in shop to here. If we include everything in shop here, right? Because product.h is already included once, we will not include it twice, but we will include this guy. It's basically copy paste, right? We are copying this part to product.h. If I'm trying to include this guy, I am copying this one here. If you are trying to include this one, you are copying the content from include.header, right? Shop.header in here. And as you can see, when you are in here, you haven't defined what is product. You never define what is product yet. So we indeed have a technique called forward declaration, right? What we can do is, all right, if you don't know what this one means, let's have a forward declaration. I don't want to give the details about class product, but I just want to give a declaration, right? I declare there exists this guy. So what we can do is we can use this. And when we are copying all the code to my product.h, it's include shop.h. It's indeed including these guys, right? Now it's fixed, indeed. Now it's fixed, right? Because the product, you know it's product, right? You know it's product. This one is product, no problem. And shop has a definition. So here we have a shop definition, no problem. So all the definitions are resolved, right? It can work. So we can make this one back. So the only thing that's remaining is redefinition of shop. Where's the redefinition of shop? Yeah, it may in some of the places. Let me see. Redefinition of shop. Yeah, it's included multiple times again. Anyway, so this one is really hard to solve, right? It's indeed, you can comment this out. It has field has incomplete type. This one is because you have circular dependencies. It doesn't know the size. It doesn't know the size of your product because you include a shop. Shop includes a product, right? So it will never know what is the size. So the bypass to that is making one of them a link. And by fixing a few things, it should work. Yeah, it succeed, right? By fixing one of them to be linked, now you are destroying the dependencies. So that is some of the techniques. I just mentioned it here. You don't have to understand all of them. Just the, but try to avoid this one, right? At least for now. When you don't know what a pointer is, just avoid that. Yeah, it should work. Where is that? Oh, I don't need the shop here. All right. Wait. Unknown type product. it should in here, it's including it. What part? Which part did I do wrong? Include product. I have a product in my product. Oh, I include this one. So that's why if you copy that part code here, the product haven't been defined. So anyway, now I'm fixing it. All right. So that's some of the ways we write, right? We said these are more efficient if you initialize your members before the body of your function, right? Using column, initialize your member with some variable, initialize your member with some variable. As you can see, you can use the same name here. The first one is a name, second one is a name, right? Initialize name with name, initialize salary with salary. If you put your code in here, it has no confusion because everything before this parenthesis is your member. Everything before your parenthesis is a member, right? So there will be no confusion. And we can also write something like this, right? Write your default constructor in this way. So another thing we want to talk about is the, we have already said that is about with parameters, right? And let's see. This is something we talk about if we want to initialize your time with something. It's indeed initialized twice, right? It's initialized after this column, then it's initialized in here. It's indeed a copy, right? Overwrite. You are creating a new temporal object trying to overwrite everything that's already initialized. So that is something we talk about. And we said this way is more efficient. It's only calling the constructor once, right? The first part of code calling the constructor for time twice. The second part calling the constructor just once. So the second part is more efficient. We would suggest you to write it in this way, right? It's suggested. And you can test them by printing out like this one, right? If you understand this one, you can understand the previous one. If it's doing, let me go this. If you are trying to create a C, it's indeed calling C's constructor, right? So in C's constructor, before this brace, it's indeed initializing B first. Initializing B means calling B's constructor in here. Before this brace, it's indeed calling A's constructor first. So it will output A constructor, then output B constructor, then output C constructor. You can test this code and try to understand the order of. If you understand the order of this output, you will know the exact order of every object, every member when they are initialized. So next questioning is, we don't want to write this amount of code. Let's see here, right? We have write one version with no parameters. Write one version with one parameter and one version with two parameters, right? How about one version with three parameters? So that's really tedious. Can we do something smarter, right? We don't want them to be here. So one technique is called default parameters. So let's see if I have a function f and p int q, right? It seems like accepting three variables. But what I can do is I can make this one some default values, make this one some default values, right? Now this function can accept f of 1, can accept f of 1, 2, can accept f of 1, 2, 3. So this is this function. Let me copy them out to here. All right, so for any function, you can write like this. Give the default values, right? Sum equals n equals 2 plus p plus q. You can write any function like this. Then it accepts all these different versions, right? even the first version, you don't need it. You can say int n equals to 1. Right? Now it accepts 4 different versions of calling this function. And the first one says, let me make a breakpoints here. Maybe 1, 2, 3 is better. 2 and 3. Let this one be 4. 4 and 5. 4, 5, 6. Right. If you create a breakpoint in here, as you can see, this f function is indeed calling it here, right? With the first guy assigned to be 4, and for the remainings, they are with the default values, 2 and 3. They are default. So in this function, it can accept 1 argument, can accept 2 arguments, can accept 3 arguments, right? Can accept 3 arguments. So all of them will work. If we apply this technique to our constructors, what we can do is we can give some of the initial values, such as in here, how about name equals to a test, right? Price to be default 1, score to be default 0. And let me use our way to initialize it. Name initialize with n, price with p, and score with score. Then everything can be deleted. This one can be deleted, right? Now this function can work for no arguments, can work for 1 argument, can work for 2 arguments, can work for 3 arguments, right? So because you have default ones, you can have different versions. Now you don't need this one. You don't need the one argument version. You don't need this no arguments version, right? This is the only thing you need. And in here, what you can do is, let me move this one up. In here, you can have, let me comment this chop out. You can have no arguments, 1 argument, 2 arguments, and also 3 arguments. You can have 3 arguments like this one, P4, and call it P4, name P4. All right, so if we want to print it, the first one is using the default one, right? P1 is using the default name, test, and the default price 1, default score 0. The P2 only changed the name, right? Only changed the name to P2, but didn't change the default value for price and the score. Next one, changing the name to P3 and changing the price to 100. So it becomes P3, 100, and 0. And the last one, it's both changing the name, the price, and the score, right? It becomes P4, 100, and 100. So this one, even you're writing it in just one file, right? In one function, it indeed represents four functions, right? Represents 4 functions with 1 parameter, 0 parameter, 1, 2, and 3 parameters. So this one is very efficient, right? And also we said, if we want to separate this implementation with a declaration, we could put them in our product.cpp file, right? How can we do that? Let me put this one to this file. And we said in order to make it in a separate file, it should be like this, right? And also in here, you shouldn't give the implementation details, just declare such a function exists. And in here, you give the default values, but the default values cannot be put in the implementation details. It should be in the declaration, but it shouldn't be in the implementation. As you can see, there are some errors, right? Redefinition of default arguments. We are redefining what is the default arguments for n, because you already defined it, right? Tested to be default value for n. So in here, you have to remove them. You have to remove these default values. And let me comment this out, right? So this is your implementation. This is your implementation for your constructor. It didn't include these default values. Default values are in your declaration, in your header file. This is in your CPP file. It's defined outside of your class. That's why we use product, column, product, right? This is how you define the member functions outside of your class. This is how you declare with default values. This is how you declare with default values. So if we come back, and you can see in your implementations, these default values should be omitted. You shouldn't redefine them. And this is how you can call it, right? With 1 argument, 2 arguments, 3 arguments. Because in this version, I didn't give the default name for the default value for the first argument. So you cannot using this constructor to call the default one, right? It doesn't include the default one. It has to have at least 1 argument in here because I'm not giving the default one for the name. So with that, if we are trying to reset an object, right? If you think about constructor as a typical function call, like if we think about the constructor as a typical function call, like the print, right? Print is just a function in here. If you can call print in here, you would think, okay, can I call product in here, right? Can I call p1 dot product? Because print is a function, is a member function. Product is also a member function. Can I call that one so that I can reset my name, my value, my score, right? If I want to reset my name to be test1, I want to reset my name to be p1, right? But indeed, it's not allowed. It's not allowed to call in this way. It's because constructor can, the object is constructed. You cannot call it using another way, right? That's the only way constructors are called, is by creating 1 object. There's no other way to call it. So if you want to reset this one to be some values, you could say overwrite, right? You're trying to create a new object, a temporal object, and using that object to overwrite whatever is in your P1. So it's indeed 2 objects created, and P1 is created, and another temporary product is created, and using that one to overwrite your P1, right? So that's the correct way. You cannot call this one. It's invalid. It's because it's not how you use a constructor, right? So this is a way, and this is how we can use it, right? If your class allows copying, then this one is what we are doing. So another way to use this kind of constructor is, for instance, you have a long version of constructor, right? I could use this constructor in other constructor, like the default constructor. I don't want to implement on my own. I can immediately call the other constructor, right? I can immediately call another constructor with some default values I want to give to my default constructor. I can do this. As you can see, this one is before this braces, right? So a little bit weird to see this one put in here, but anyway. So another topic we want to cover is called uniform initialization. This one is very important. I would say this is very useful as well. So in the past, we know how we can initialize your object, right? This is similar to a function call. As you can see, parentheses, like the print parentheses. It's a function call. But here we use braces, right? Instead of using parentheses, we use braces. So as you can see, everything I write in here is using parentheses, right? It's a function call. You are calling which function? You're calling this function, right? Function is parentheses. But in the, I wouldn't say it's a new way, but it's already existed there for many years. It's really helpful. Let me test that. So void test uniform So the reason it's called uniform is because it can apply to almost any type. Right? You could say, what if I want to initialize an integer with 0, right? You could write it in this way. I'm initializing an integer with 0. Uniform initialization, right? Double B with 1.0, right? Initialize a vector with 1, 2, 3. Yeah, just 1, 2, 3, right? It's uniform initialization. It applies to almost all the types, right? So the reason people now accepting this one is sometimes it is better than assignment, right? Sometimes, for instance, in the past, we know about casting. It is allowed to cast an integer to double, right? But sometimes it's, let me see, let me test that. And F with A, it's not allowed. You cannot, it's a little bit different than assignment, right? You would think this one is exactly as similar int A equals to 0, right? You would think this one is exactly the same as double F equals to A, but indeed it's not. It's not allowed. It requires you to cast this guy. So we have learned static cast this guy to a double, then it will be no issues. So so in the newer standards of C++, it's trying to make your code more stable, right? And make other people understandable. So they are trying to force that using this braces. But don't forget about it. Let's just forget about it. Too much details. So this is a uniform initialization. This is also uniform initialization. Let's call this one table 5. Just 2 elements are enough. What is this one? Remember what it is? It's creating 5 zeros, right? Because it's a vector of integer. You have 5 integer 0. This one is a vector of a vector. You are creating 5 vectors. Each vector will be initialized with 1 and 2, right? Each vector will be initialized with 1 and 2. So this is the uniform initialization. All right, let's continue. What is this? What is this? I am creating 5 products, right? It's a vector of product. I'm creating 5 products. Each product will be initialized with A. You're calling a constructor with just 1 argument, right? So that's basically a uniform one. So the reason we prefer uniform is sometimes, for instance, if I'm trying to a product, right? For instance, if it's a, give me some name, give me some price, right? What you can do is, okay, how about I return a name, a price, and a score 0, right? This is something you can do. It's returning a uniform initialization, right? It's called initializing list. You're returning an initializing list, using this list to create an object, product object. This is called create a product, right? You're returning a product, but you are indeed returning this guy. So let's try this. So int main product P equals to create a product with some name. Let's this name called creating product 100, 1,000. All right, so let's P dot print. This one should be at the beginning, right? And let me comment this out. So as you can see, it outputs this one, CP, 1,000 and a 0, right? You are using this initializing list to creating an object, right? You are returning that object. So that is a something we can do. All right, any questions on the initializing list? This one are very useful, and there are many usages, especially the ones I'm trying to cast one type to another, right? And in the future, if you learn more, you will see this guy is called initializing list, and you can create one file inside your class to specify how you can initialize your data using a initializing list. But that's another story when you are learning more about classes. I think that's basically you need about uniform initialization. So both ways are fine, both ways are good. But personally, I would sometimes prefer this one. Yeah, but both ways are good. You can use both anyway, right? The first one are more straightforward because it's calling a function, right? Calling the constructor function. It's more straightforward. All right, so about accessing which field, right? We have talked a little bit about it. We are assuming the salary is a private member of your employee class. If you are trying to define a function called raise salary outside of your employee class, we call this one a non-member functions. If it's not a member of your employee class, you cannot access its private members, right? We mentioned about that. Only the public interface, like if they allow you to get a salary, you can get a salary. If they allow you to set salary, you can set salary, right? If you don't have this kind of public interface, you cannot do that. But if they apply and they provide it, you can use it in this way. And this is how you can modify the fields or modify the members of your of any object, right? This is how you can do it. As you can see, it makes the writing more tedious. It's just one line. Next one is 2 lines with another 2 function calls, right? The first function call is get salary. Next function call is set salary. So it's more tedious to write it, but it allows you to control who can access your data, right? So class is more about encapsulation, about protecting which data cannot be accessed from outside. So we say not every data member needs an accessor, and not every accessor need a matching mutator, right? You don't need a setter for every getter. So that's the basic idea. And also in our product, we said in our product, even though we have a get name, right? We don't have a set name, right? We only allow the user to set a price, for instance. So it's totally valid. For instance, whenever a product is created, it is assigned the name. Then from the future, you cannot change it, right? The only way you can query is get the name. You cannot change the name. So that will be something we typically do. And also the get score. Sometimes we said we don't allow the user to set arbitrary score. The only score we get is by running some benchmarks. Then that will make sense, right? And also we said if even the name is called, for example, get minutes, it don't have to be some minutes that is stored in your private members. It could be computed by many functions, right? For instance, if our time class only contains the seconds, if it only contains the seconds, if the user is query get minutes, right? It don't have to be something called a minute stored. It could be computed by the seconds. So that is also a typical way And if we compare, right, from the non-member functions versus a member functions, a member function is implemented inside your class, right? If it's implemented inside your class, you can immediately modify the private members, and this salary belongs to the object you are calling, right? Whoever is calling raise salary, you are modifying their salary, right? And also, if it's the function is implemented outside of your function, this object has to be one of the parameters, right? Have to be one of the arguments in here so that you can modify this is salary. So, and also here is how we can use it. If it's a non-member function, we say raise salary with some object, right? And the remaining arguments. If it's a member function, it's this object dot the member function, right? With the arguments. So that's the difference. And also in one of your member functions, you can call other member functions, right? Inside your class. For instance, if your employee has a function called get name, you can call get name, right? If it has a get salary, you can call get salary. The reason we do that is sometimes, for example, if people have a get name function, it may be nicely format your name so that you don't have to implement the formatting again. You just maintain the formatting of your name in one function and use it, right, over and over. So that's the benefit of calling a member function inside another function. And this time you can try to implement this one because this one is quite easy actually. It's and you can see this one I'm making the problem simpler because I am allowing you to remember the minutes, right? Remember the minutes, remember the seconds, remember the hours. If I say I only allow you to remember the seconds, the implementation should be different. So anyway, you can try this one. Because matrix, you haven't learned linear algebra, so I will skip this part. So last topic I want to cover is called aliasing. Alias, we have learned that when we talk about reference, right? We said reference is an alias. It's just another name for the same guy. So type, we could also give a type a new name. For instance, if we have a account, right? Let me copy this. Account.h. So for instance, if I have a called, let me delete this part first. For instance, if I define my balance to be an integer, and I have a function called get balance, I would return my balance, right? For instance, this is the starting point. What we want is, for instance, in some day, we want to change from integer to long on the, for instance, long, and this one becomes long, right? You need to modify every place balance appear as integer to long. So in order to avoid that, what we can do is, how about we can define a type, let it be, for example, long to be called money, right? Or the currency, it's also fine. And we can replace everywhere the balance type to be money. So for instance, for the beginning, you want an integer to be money, money to be integer, then you can say type define integer to be money. Then every place money appear, you don't need to change, right? It is consistent. For some time, you want it to be double, you just change it to type define double to be money, right? And also, for example, you have a factor of double as the transactions, right? For instance, someday you want to get all the transactions, all the transfer money and also payings, and you can have, for example, you have a very long stuff called a get and transactions, right? Return transactions. You can, as you can see, this one is really tedious to write, right? What if in the future this one becomes factor of integer, right? And also many places you need to change. So what you can do is you can define a new type, maybe call it a this guy, copy it here, and I call it trans. All right, so from now on, you can make this one a trans, and you don't need to make this one over and over again, right? If in the future you are not satisfied, make it int, it can work, right? So that is type defined, the usage. First benefit, you can reduce the time to modify the things you want to change, right? Even if you are search for instance, if you are trying to change from money from int to double, you are trying to replace integer, you are searching for integer, but there are many places integer are there. So it's very hard to do. The best way to do is, right, you can just make this one a type defined. So this is the old way. People typically use a type defined. The new way people use is called using. Using transactions equals to this guy. These two are basically the same. Basically the same. You are defining a new name. The first one says I'm defining this type to be transactions. This one says I'm using the new name to represent this guy, right? So they are basically the same, but I would prefer the using. Using money equals to double, right? So the using is the way I prefer. Indeed, you already see using, right? Using, right? Using namespace as is using these keywords. But anyway, so in here we have that, and maybe for now, maybe it's not so useful because the types you write are quite easy. In the future, when we learn, for example, maps on all of the sets, vector of map, a vector of something, and a long one, it will be very useful to use something that's make your typing